Okay, in this section, we're going to keep solving. So let's take the problem. 2 sine of x over 2 equals 1. And we're going to just call this theta for a second. So 2 sine theta equals 1. You tell me to divide by 2. You get sine theta equals 1/2. So in this part of the problem, we were given an interval. So theta equals a half. No, sorry. Sine of theta equals a half. Sine equals a half and positive half in the first two quadrants. It happens here and here. So that's pi over 6, comma, 5 pi over 6. And then we have to go back and replace what we had. We didn't have theta. We had x over 2 equals pi over 6, comma, 5 pi over 6. To solve for x, you have to multiply both sides by 2. So you would get that x equals 2 pi over 6 and 10 pi over 6, which equals pi over 3 and, I click the button, pi over 3 and 5 pi over 3. So these are our two answers. So just because you have something inside of those parentheses, you can call it a different name, a nickname, a theta, solve, and then undo that. Keeping the same idea in mind, we get into letter B, all the same work. I'm just going to skip down to the very last step-ish thing. I'm going to use red. I have theta equals pi over 6, but then I have to add plus 2 pi n. Because it happens every 2 pi, forwards and backwards around the circle, but every 2 pi, and then I have my other answer, 5 pi over 6 plus 2 pi n. This wasn't a theta, it was an x over 2. So we had to multiply everything by a 2. And when you do that, you get x equals, we know that it becomes a pi over 3, but the 2 also has to go to the 2 pi n thing. So plus 4 pi n, comma, we know the other one becomes a 5 pi over 3 plus a 4 pi n. Oops. Okay, we're going to do more of this with now double angles. So if you look at number 2, do you see how we have the same trig function but different angles? Well, that's not going to help me very much. So I'm going to replace this cosine 2 theta with a double angle, and I'm going to pick one that's only a cosine because I have a cosine on the other side of the equation. So I'm going to replace the cosine 2 theta with a 2 cosine squared theta minus 1 equals cosine theta. Now I have the same trig function and same kinds of angles. So 2 cosine squared theta minus cosine theta minus 1 equals 0. I'm going to make it equal 0 because I'm going to factor. So I'm going to do 2 times negative 1 is negative 2. I need two factors of negative 2 that add up and make this negative 1 right here. So negative 2 and positive 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is my negative 1 in the middle. So I'm going to rewrite this term right here as minus 2 cosine theta plus 1 cosine theta. I didn't change it. If I combine like terms, I'll go back to where I was. And I still have my 2 cosine squared out front. And at the end, I still have my minus 1 equals 0. I'm now going to make two groups. This blue group, they have a 2 cosine theta in common. And that leaves a cosine theta minus 1. My red group right here, I pull out a minus 1. I'm left with a cosine theta. No, sorry, I'm going to pull out a plus 1. That leaves me with a cosine theta and a minus 1 in the parentheses. The two things in parentheses match, and that's how you know you are doing it right. I'm going to pull out the parentheses from both groups. I get cosine theta minus 1. Pull that out of both of them. I'm left with, in blue, 2 cosine theta. And then in red, plus 1 equals 0. What I just did, you can also do if you factor by using a box, but I prefer not to use the box, so I factor by using grouping. You take each piece and you set them equal to 0, so cosine theta equals 1. Sorry, I already moved the 1 over. And the other one, cosine theta equals -1/2, because I added this over and divided by that. So note you have an interval. So where does cosine equal 1 in that interval? Well, that happens at 0. Cannot call it 2 pi, because that has a parenthesis, not a bracket on it. And cosine equals a -1/2 at negative, so I want to be in those two quadrants. So it's going to be 2 pi over 3 and 4 pi over 3. So this is my solution. Your book often writes it as a solution set, and they do 0, 2 pi over 3, 4 pi over 3. All the same thing. The next one's a little tricky, only because it doesn't equal 0. I have two different trig functions. If I move the √3 over, I still really can't factor. So it is very plausible, and in fact it is the case, that something is hiding. So I have 4 sine theta cosine theta equals √3. I can rewrite the 2 without, or the 4 without changing anything, as 2 times 2 sine theta cosine theta equals √3. And hopefully you recognize this as sine of 2 theta. It's a double angle formula. So I have 2 times sine of 2 theta equals √3. I can divide this 2 over right here. And when I do that, I get sine of 2 theta equals √3 over 2. Okay, so then I have 2 theta equals, oh, nope, sorry, I forgot the sign. No, actually, I'm okay. So I have to answer the question, where does sine equal √3 over 2? So I'm going to write down the 2 theta equals, and then where does sine equal √3 over 2 in my interval, in degrees this time. So positive, sine is positive in the top quadrants. So that's going to be at pi over 3, comma, 2 pi over 3. Okay, so I hope what I'm about to say makes sense. We are going to divide everything by 2. So any more answers right now don't seem like they fit in this interval. Oh, and mine don't either. Let me fix mine real quick. This happens at 60 degrees and 120 degrees. Now mine are better. But when I divide them all by 2, answers that were outside my interval might now fit. And so the rule of thumb is, since I am multiplying my angles by 2, I should list 2 times as many answers. So if I have 2 answers in one circle, I should list 2 more. And I find 2 more by adding a circle, by adding 360 degrees. So I take this one and I add 360 degrees. You will get 420 degrees. And if I take this one and do the same thing, I will get 480 degrees. And then I'm going to divide everything by 2 so I can solve for that theta. So theta equals 30, 60, 210. 420 is outside my interval, but 210 is definitely inside my interval. 480 is outside my interval, but when I divide by 2, I get 240, which is also inside my interval. These are the answers that I want. And if you're not sure if you have enough, you can go ahead and you could take this one right here and add 360 again. You could do 420 plus 360. That would get you 780. And when you divide 780 by 2, you get 390. That is outside of my interval. So when I don't give you a restriction, there's a little bit of thinking you have to do to make sure you have all the answers listed. In the next one, the trade-off is I didn't give you an interval, but now you have to remember just a little extra step. So I get 2 theta equals 60 plus, because there's no interval, 360n. And then you do 120 plus 360n, and you will use 360 because sine's period is 2 pi or 360 degrees. If this were tangent or cotangent, we would use 180 or pi because that's its period. Divide by 2. Divide everything. Everything here needs to get divided by a 2. So you're going to get theta equals 30 degrees plus 180 degrees n. The other one you're going to get is 60 degrees plus 180 degrees n, where n is in the integer. Okay, last problem for your notes. So this one is super not nice, in my personal opinion. Secants and tangents together, and 3x's and all kinds of stuff. And I only know how to make secants become tangent and tangents become secant if they're squared, so we're going to have to square both sides. But before you do, I would move a trig function to the other side because I don't want to have secant and tangent together when I start squaring. It will become a nightmare. So I'm going to do tangent 3x equals 2 minus secant of 3x. And I'm going to square both sides. This side is the same thing as 2 minus secant 3x times 2 minus secant 3x. So if you need to FOIL it out, by all means, please go for it. This side becomes tangent squared 3x equals 4 minus 4 secant 3x plus secant squared 3x. On the right side of the equation, I definitely have more secant stuff. So I'm going to change this thing right here by a Pythag. I know that tangent squared theta plus 1 equals secant squared theta. So tangent squared theta equals secant squared theta minus 1. So this piece is going to become secant squared 3x minus 1 equals my 4 minus 4 secant 3x plus secant squared 3x. And you will notice that when you go to combine like terms, this secant squared and this secant squared are going to cancel off, which is beautiful. So I have minus 1 equals 4 minus 4 secant 3x. I'm going to move the numbers over the other side. So I'm going to minus the 4 over to the other side. So I get negative 5 equals negative 4 secant 3x. I'm going to divide by the negative 4. So you're going to get a 5 over 4 equals secant of 3x. I'm going to call this theta for a second. Just call it theta. I can do this is the same thing as cosine of theta as long as I flip the other side like that. If you don't like that thought, you can also do it like this. 5 over 4 equals 1 over cosine of theta. Multiply the cosine over, so you get 5 cosine theta over 4 equals 1. Multiply the 4 over, and then divide by the 5, and you will get to the same place, or cross multiply. All of those ways work, but I use a little shortcut. So 4/5 is on my circle. It is between the negative 1 and 1 where we know that cosine lives, but it is not something I know. So you can grab your calculator and you can type it in. Before you do that though, 1 we have an interval, so 0 to 2 pi, first of all. Second of all, we're going to divide all our answers by 3. So I'm going to need 3 times as many answers. So the calculator is only going to spit out one answer because we're going to have to use hot lava. So hang on one second. Cosine's hot lava is right here. Cosine is positive in this quadrant. So this is the answer the calculator is going to spit out. It's not going to tell me this one down here because of the arc, but I'm going to need that blue one. So in my calculator, arc cosine of 4 over 5, and press equals, and it's going to give you an answer in radians. Please be in radians because that's what the interval is in. And that answer is 0.6435. That's my black answer. To get to my blue answer, which also exists, so to find that other answer, this distance right here was the 0.6435. So this distance is a negative 0.6435. That's outside of my restriction. So if I take the whole circle, which is 2 pi, and I subtract away the 0.6435, that's this distance that I'm looking for. And so when I do that, my next answer is 5.6397. Again, I got that by doing 2 pi minus the 0.6435. That's only two answers. And so remember, this was not a theta, this was a 3x. So I should list 3 times as many answers. So I had to add 2 pi to my first answer, this 0.6435. I add 2 pi, and when I do that, I get 6.9267. Add 2 pi to my 5.6397 and get 11.9229. So here's 1 circles, 2 circles. I need one more set of answers down here, one more. So add 2 pi to this right here, and you should get 13.2009. And then last one, I'm going to add 2 pi to this one, and when I do, I'm going to get 18.2061. Now you have to take all of these things, all of them, divide by 3. So I have to solve for x. So x is going to equal 0.2145, comma, 1.8799, comma, 2.3089, comma, 3.9743, comma, 4.4033. Last one, 6.0687. Remember, I had an interval only go to 2 pi, and 2 pi is 6.28, but my last answer is just under 6.28. So it fits inside my restriction, and there are all of my answers.